Hello students, hope you all are doing well and you all are also studying well. Welcome to this video. So in continuation with calculating rank correlation coefficient or Spearman's rank correlation coefficient, this is another example we are going to discuss today. So now if you observe this example, so we have got the values for x and y and ranks are not given. So we need to calculate the ranks for this given data set. Alright, now look at the statement given. For the given data, calculate the rank correlation coefficient after making adjustment for tied marks, okay, or for tied ranks you can say. So first we have to adjust the ranks where we are getting the same rank. For example, if you look into the Y series, first two values are same, which are 13, 13. So they are going to have the same rank. Now we have to make the adjustment for the ranks for the repeated numbers, and after that we need to calculate the rank correlation coefficient. So our basic formula remains same, that is 1 minus 6 into summation of d square divided by n into n square minus 1. So now the additional thing is here something called as summation of CF. So now the formula is having this component, otherwise it was only this much. Now with summation of d square is added with summation of CF, where CF stands for correction factor. So for every item which is repeated, for every item will have the correction factor. Now if you look at this, the correction factor is given by m into m square minus 1 for each item which is repeated in this data set. Now for example, 13 is repeated twice, so we need to substitute value of m as 2 and 2 into 2 square minus 1 divided by 12. So this is the standard formula for calculating correction factor when we are applying rank correlation method. So this we have to do for every item which is repeated. Okay, then these all correction factors has to be added, and then summation of these all correction factors is considered into the formula. Okay, so now first we have to give ranks to the numbers. Okay, so now we'll have one simple example here. Now for example, we have, suppose we have 4, 4, 6, 8. Okay, suppose these are the given numbers. Then if you want to rank them from highest to lowest, then this would have the rank 1, this would definitely have the rank 2. Now these two would be actually taking the next two ranks, 3, 4, but they are same. So what we need to do, we have to take the average of next two ranks. So we have used rank 1 and 2, then next two ranks would be 3 and 4, and their average would be 3.5. So that is 3 plus 4 divided by 2. So we have here rank 3.5 for both of them. Is it? So this is how we need to give the rank. Okay, now in the case, suppose we have some rank this way. Now suppose the given data is this way. Okay, now if these are the given numbers, now in this case, first rank would be 9. Second would be 2. Okay, let me change it to 5. Okay, rank, this has got rank 1, this has got rank 2. Then these are the same numbers, so which would take the next three elements. So now the next three ranks, which are 3, 4 and 5. Average of 3, 4, 5, that is 3 plus 4 plus 5 divided by 3. So that average rank we need to give here. Now in this case, we have indirectly used all three ranks. Now next we have to proceed with the rank which is after 5, because 5 is indirectly included in this average. So then the next rank 6 would be given to this. So this way we have to give the ranks now. Okay, so now we'll begin with this. So first let me have a column called as rank of x. Then similarly I'll have a column called as rank of y. Okay, so these two columns I have added. Now in this x-axis, 65 is the maximum. So I will have rank 1 for 65. Okay, then the second one would be 57. Then third would be 48. Fourth would be 40. Then rank 5 I need to give to 33. Okay. Then rank 6 I need to give to 24. Then rank 7 I need to give to 16, and there are three 16s. Okay, so 1, 2, 3. So now my next three ranks, that is 7, 8, 9, and average of these three ranks, that is divided by 3. So this gives me 15 plus 9, 24 divided by 3, 18. So it's a simple property. If you have any three numbers which are in consecutive or continuous, any three numbers, their average is always the middle number. So the value of average of them is 8. Then the 16 will have the values 8. So for three of them, I'll be giving this rank 8, 8, and 8. Then next rank I have to use is after 9, because 9 is included in their average. So the last rank is 10, and that will be giving. Okay, so I am done with this all. Then this will be rank 10 for 9. So hope you have understood how I have given this. Okay. Now let me note this, that because later we have to calculate the correction factor. So to calculate correction factor, so now in X series, 16 is repeated 3 times. Okay. Okay, now we'll calculate the rank for Y series. So in the Y series, this 24 is at the rank 1, then 20 at the rank 2, then we'll have 19 as rank 3, then 15 would be rank 4. Alright, then after 15 we have 13. Did I miss any? Okay, we have 13, and which is there twice. Okay, so then I need to consider these two for next two ranks. Those are 4 and 5. Sorry, 1, 2, 3, 4 are done. We have to consider for 5 and 6. So average of 5 and 6 is 5.5. So for both of them, I'll have rank here 5.5 and 5.5. So I have used indirectly both the ranks 5 and 6. Then I have to proceed with rank 7. So rank 7 would be given to this 9. Okay, would be rank 7. Then the next thing is 8 rank would be given to 6, or would be given to 6. There are two 6. So again the same thing repeats. 8 and 9 rank I have to give for two of them, which are same. So average of 8 and 9 is 8.5. So this will have the rank 8.5. Similarly, this will have the rank 8.5. And now we have used 8 and 9 both. So the last rank is 10, and here the least value of. So this way we have done the ranks for both the series X and Y. Okay. Now next thing is we need to calculate as usual deviations between the ranks of X and Y. Then square those deviations, and their summation is what we require. Okay, now we'll also note here from the Y series 13 is repeated 2 times and 6 is repeated 2 times. Okay, so I'll have the account here. 13 is repeated 2 times and 6 is repeated 2 times. So now for 16 from X series, then 13 from Y series, and also 6 from Y series. We need to calculate the correction factor for all three of them. Then their addition of correction factors need to be put into the formula. We have to substitute later. Okay, now we'll calculate the deviations. Then we have to also square these deviations. So deviations I have written here. Okay, now 3 minus 5.5 gives me minus 2.5. This is minus 0.5. 4 minus 1 is 3. 10 minus 10.5 is 1.5. 8 minus 4 is 4. 8 minus 10 is minus 2. Minus 1. Minus 1. Minus 0.5 and minus 1. Okay, so I have written all the deviations. Now we need to square all these deviations. So squares are always positive. So that way we can write alright, all squares are also ready. Now if you look at the 0.25, this fraction, which is exactly 4 times, and that makes a complete 1. Okay, that means 0.25 plus 0.25 plus 0.25 plus 0.25 gives me 1. So that is one carry here. And then adding all this. So this gives me 41. So 41.00 would be the summation of d square. Alright, so our summation of d square is ready. Now we will calculate the correction factor for 16, which is repeated 3 times, 13, which is repeated 2 times, and 6, that's also repeated 2 times. So we'll calculate the correction factor for it. Now m value, we need to substitute the value of m here. So that is the number of times this particular number is repeated. So in the substitution of correction factor, which requires only m value, we have to just substitute the value of m, that is number of times it is repeated. There is no way connection with the item which is repeated. So only thing is we have to look for is the number of times any item is repeated. So this is only for our convenience we write. So if there are 2 items, then we have to make 2 entries. So this 16, 13, 6, we are not going to substitute anywhere. We are just focusing on this value of m, the number of times it is repeated. So if you substitute the value of m as 3, what you get here is 3 into 3 square minus 1 divided by 12. So 3 square is 9 minus 1 is 8 into 3 is 24 divided by 12, and this gives you 2. So the correction factor here what we have calculated is 2. So this is 3 into 3 square minus 1 divided by 12. We have calculated is 2. Okay. Similarly, we have to calculate for this value of m, which is 2. So that is 2 into 2 square minus 1 divided by 12. So 2 square is 4 minus 1 is 3 into 2 is 6 divided by 12. This gives us 0.5. So this is 2 into 2 square minus 1 divided by 12. This gives you 0.5. Same thing is for the item 6 also, because that's also repeated 2 times. But we have to calculate for every item which is repeated. So though it's the same value, we have to consider. So this also gives us the same value, that is 0.5. So it is 2, then 0.5 and 0.5. So addition of 2 plus 0.5 plus 0.5 gives us 3. So the correction factor summation is 3 for these numbers which are repeated. So now let me substitute the values into the formula. So it is 1 minus 6 into summation of d square is 41 plus summation of correction factors is 3 divided by, now here we have got altogether 10 values, the last rank is 10, so it's 10 into 10 square minus 1. So this gives us 1 minus, so this 41 plus 3 is 44 into 6, that gives me 264 divided by 10 square is 100 minus 1 is 99 into 10 is 990. So let me calculate. That is 264 divided by 990 gives us 0.26, and that has to be subtracted from 1, that gives us 0.73. So we have got the value of rank correlation coefficient is 0.73. This is the final value which we have calculated. Alright. So hope you have understood this example. So what you have to do, you have to always consider the repeated ranks and you have to give the ranks. How do you give the ranks? By the way, you have to consider the average of those ranks. So those could be any rank. It can be 2 and 3 or 3 and 4. So any continuous ranks. So their average has to be given, and for every such item which is repeated, we have to calculate its corrections factor. Okay, so that's important. We have to calculate its corrections factor, and these summations of all these corrections factors has to be substituted into the formula. So that's the integral part of this, because of the ranks which are repeated, we need to settle down. When we average the rank, we have to also consider its correction factor. Alright, so when ranks are repeated or when the values are repeated, you have to give the ranks in the form of average and its correction factor has to be calculated. Then substituting that, we will calculate the value of rank correlation coefficient. So Spearman's rank correlation coefficient is calculated in this manner when values are repeated. So hope you have understood this example. Similar such example you try to solve on your own. Okay, also solve the examples given in the notes. Alright, then we'll see you in the next video.